First, I want to welcome you all to my G0704 built from the ground up video. The picture you're seeing here is the first video, or the first mill I had. I found it on Craigslist and purchased it, but I found that it had some limitations that I just didn't like. Some of those limitations were that it had a 5-inch Z-axis, which is great, except when you want to switch between a collet and a drill, you don't have enough room and you got to crank it up on the column. I didn't like the round column either. It had a tendency to shift when I did bring it up, and I'd lose registration. And the third thing that I didn't like was the speed. I couldn't get more than about 2,700 RPM out of it, and that was on a good day. And when you did that, it sounded like it was going to take off, and it wasn't variable speed. So those are some of the reasons why I decided to do my own build and see if I could make a better machine myself. First, I want to recognize G0704.com. What a tremendous job he did, both on his YouTube videos, and that site is wonderful. It's given me some great ideas about what I want to do with my build. That being said, some of the reasons I decided to go with this model was the fact that although it's a smaller machine, it has about equal the same capabilities as the other machine. With the difference is it's got a 13-inch distance from the spindle to the travel, or the travel to the table. The table travel is 18 7/8 inches, which exceeds the one on the central machine that I had before, and the table travel was 6 7/8 inches. It's a little smaller travel than I had on the central machine, but I'm considering putting that dovetail in the back that G0704.com did in one of his videos, and I believe that would give me more than the travel that I had. So I started my build with a computer. The computer I had in the old mill was overheating a lot, and because it needed a parallel port, I kept buying some old Dells to support me, and I went through 3 of them before I finally gave up on them. The garage was just getting too hot in the summertime, and that made it difficult. So after that I said, well, let's see if I can build my own computer, and that's how it started. So what I did is I used a server case. I had a plan of mounting it underneath one of the toolboxes I have, and the server case I liked because it came with 4 fans, and I thought, well, if that should cool it down enough in the summertime to keep me running. So I did do that, and you can see in these pictures the case, and I've mounted it in the toolbox, or underneath the toolbox that I got from Harbor Freight. So this next picture is what I did with the computer monitor. I bought a server keyboard and mounted that in there, and I've got the monitor inside the top of the Harbor Freight toolbox. This turned out really well. I was really pleased that I could do that. As I open up the toolbox, the monitor comes out. It's pretty slick. This next picture is a picture of the old driver box for the central machine mill. It was actually housing some servo drivers, and the motors for the other central machine was servos. I learned a lot from this box. One of the things it didn't have was it didn't have a breakout board. It wasn't opto-isolated or anything, and that kind of freaked me out. And I had I think blew out one printer port because of this, where I had some feedback coming back over the outputs. I don't know that for sure is why it blew out, but it did destroy a computer for some reason. So I decided to go build my own box, and I couldn't find a box online that was going to meet my specifications. So I looked at computer boxes, and I said, no, they're just too flimsy. And so I said, hey, I'll come up with my own box, and I did. So I built the box out of 062 aluminum with a 1/4-inch backplate, and the idea of the 1/4-inch backplate was to provide a large surface that would make a nice heat sink for all the drivers and the things that I was going to attach to the inside of the box. So that was the reason I made that the way I did. I had the opportunity to use a water jet cutter, so I cut the back of all the holes in the back there you see with a water jet cutter, and then in the front of the box I used a friend's CNC mill to drill all those holes in it, and it worked out really well. The overall fit and finish of the back was incredible. So all the parts, components that went into it just slid in beautifully with very little filing. Here's another view of the box. I had it all assembled there with the hinge on it, and now you can get a good look of what's inside and again see some of those holes. So this is the box as it looks right now. I got several inputs in there. I put 2 DB25s and 2 RJ45s and 1 USB. Kind of an idea for having expansion there. You can see I used what I think is called an XLR connector there, 4-pin, and I added 2 110 outlets in the back of the box as well. They're both switched, but again, box turned out great. Like I said, fit and finish looks excellent. Just loved how everything went together there. So I've got my motors set up, and I'll show you those in just a minute. I don't think I'm going to run them yet here, but they are running, up and running, and they work out. It just worked out great. So as I was saying earlier, the plastic mounts I made on another CNC machine, I didn't like how the wires just hang out of the stepper motors, so I encased them. This is a piece of Delrin that I cut on a CNC machine, and then put terminations here, and you can see they got the same terminations in both ends, and you get a kind of a look at what one looks like there on the A-axis. It's a 3-axis box right now. I didn't put the A-axis in yet, and you can see that I've got some inputs here. I added a lot of inputs thinking that I could use them as I expand the machine. I put 2 DB25s thinking I was going to control 2 C10 breakout boards, but I ended up getting a smooth stepper, and so I've got the USB cable in the middle and the Ethernet terminations there, which one of those is going to be used for all the homing, limit switches, and the safety emergency stop there. That's the USB cable going into it. The box looks like it's a little bit of full spaghetti right now, but it turned out okay. So if you look starting at the bottom, I've got a 48-volt power supply. The power supply and the all the motor electronics came from Automation Tech, except one piece. I bought a few things that I guess I bought online on eBay that I found. Right above the 48-volt power supply, I found a 12-volt, 5-volt power supply regulated that is sitting right here, which has been great. I'm using it for a variety of reasons I'll explain in just a minute there. So I got those 2 power supplies, and then I'm using the Kelling Technology KL650s. I've got 2 of those in there for the X and the Y, and then this one down here is actually a KL860 or 8060, excuse me, which is going to be for the Z-axis. Over to the right, you can see this C10 breakout board, and then above that is the smooth stepper that I've got in there. So it's really hard to see, but underneath here, as I come up there, is a charge pump that I bought from CNC PC. It's a pretty cool device. I was having a problem with the C10. It was taking everything high when I first turned on the machine, making things to go on, and I didn't want them to go on, so this was a nice safety to add to the machine. It took a little bit of time to figure out how it worked, but it worked out pretty nice. So a few more things that I added to the box. I mentioned before there's a 5-volt power supply sitting on top there, and that supplies 5 volts to all the boards, the smooth stepper and the C10 motherboard, or breakout board, excuse me. And then as you can see, I got 2 solid state relays. One of those is, well, they're both set up for the outlet that's in the back, and then below that you'll see that I have a little board I made which has 2 5-volt relays on it, and they're 5-volt relays to 12 volts. So I've got 2 12-volt outlet outputs in the back of the box, which will control mist coolant and some flood cooling if I want it. So this is the computer again, and I don't have anything else to really say right now. My next steps for this project are to go ahead and order the mill and start working on it. So I'm going to order it, hopefully get it by Thanksgiving, and move it down into the basement where I can disassemble it and start putting it back together. So until then, I appreciate you guys watching and hope you have a nice time in your machine shop.